want to have a look at again, another real problem solving one. There's lots of these in your exam papers. If you find that you're in an exam and you feel, you need to really think about it, maybe leave it until the end and see how much time you have to devote to it. So a good one to have a look at is 2016 question 2, and if you want to, you can pause the video so you can have a read of it, or you might be able to find it online. So I'm going to keep going. Now part A is a very nice part, junior cert information and just basic information on the line. They said point X, which is here at -1/6, and the slope of this XC here is a 7th, and they want me to find the equation of XC in this form where A, B and C are going to be integers. That's very straightforward. Y minus y1 is equal to m bracket x minus x1. And then you're just going to clean that up, and when you clean it up and move it around, so that'll become a plus obviously, and you get rid of your fractions, you'd end up at x minus 7y plus 43 equals 0. So that's pretty straightforward. Very nice of them to, even give me any marks to doing that. The next thing is that part B. This is the centre of the circle, calling it minus G minus F, which I'm used to for my log tables. They've told me it's a radius length of 5. And we have this line here, which is a tangent that goes through the point -1/6. And they want me to find the equation of one such circle. So there must be 2 possible answers here, like maybe if we continue on this line here, and this one, maybe there's another circle over here somewhere, and I'm going to get both possible answers so that no matter which one you find, you'll know which, if you have it right or not, if you found it out correctly. So I'm going to start by looking at the fact that I'm going to go to my log tables, because there's nothing that jumps out at me straight away. I mean, if I need the center point, I have the radius, so that's really what I'm looking for, is to, if I could figure out what minus G and minus F were, well, I'd have enough to write down the equation of the circle. I maybe go to my log tables, as I said, and I start having a look, and I'm thinking, okay, right, slope. Is there anything about slope? Well, can I get the slope of that line? I have it, it's a 7th. Can I get the slope of that line? I can, because I have the equation of that line. Okay, so that's possible. That might allow me to get the tan of the, the angle between the 2 lines if I have the 2 slopes there. And what might that do? Well, I don't know, I'm just thinking here that I'd have that angle, I know that's 90, and I'd have that angle, but I can't see how that might actually find me this particular point here. So I'm going to say no to finding the slope at the minute. Distance, so my junior cert distance is next. Well, can I get the distance between there and there? No, not using my junior cert formula. And I know the distance between there and there. Anyway, so no to distance. Next is midpoint. I don't see again what midpoint is going to do there. Find the equation of a line is the next one. Well, I have the equation of that one, I have the equation of that one, so unless I want to find the equation of that one, which would require a point on the line, which I don't have. So it seems like too much missing information there. I could get the area of the triangle formula, but I don't, I don't have that. No, sorry, I do have that, I don't have that, and I don't have that. Again, I think there's too much information missing, and I don't know what the area of the triangle would do for me there. Dividing a line segment into a given ratio. No. Next is the perpendicular distance formula. Now, if I got the perpendicular distance from that point to this line, which I have, I'd know it's 5. So that could be worth considering. The only thing is I'll have 2 things missing. And if I have 2 things missing, it means I'd have to somehow maybe use simultaneous equations or something like that. So perhaps I might consider perpendicular distance, because you know I actually, my last one here to consider is the angle between two lines, and I've already thought about that just with regards to slope. So maybe I'm just going to have a go with perpendicular distance. So I've looked through my log tables. I've really considered perpendicular distance. I think I'm going to have a go at that, but I probably need another bit of information because I'm going to end up with two things missing. So I'm going to do that first because at least that's a start, and then I can figure out from there maybe what I want to do. So the point minus G minus F, and I want the perpendicular distance from that point to the line that they give me, which is 3x plus 4y minus 21 equals 0. And I know the perpendicular distance is 5 because that's the length of the radius. So I'm going to fill in my perpendicular distance formula. A times x1 plus b times y1 plus c all over the square root of a squared plus b squared, and that's equal to 5. I'm going to clean this up a little bit. Minus 3g minus 4f minus 21, and that's all over 5 equals 5. Excuse me. Bring this over, it becomes multiply. And this is as far as I go for the minute now. I could go a tiny bit further. Like, I mean, to deal with these lines here, I either just want to square both sides, which turn it into something ridiculous. So I want to understand that what these lines mean. So they're the modulus, and it means what was in here. It could have been a minus 25, or it could have been a plus 25. But when we put these lines on it, it definitely was a plus 25, no matter what was in here. So I have the fact that we've minus 3y minus 4f minus 21 equals 25 is one option. Minus 3f minus 3, that's a g, sorry. Minus 3g minus 4f minus 21 equals minus 25 is my other option. Again, I can clean that up a little bit further. Minus 3g minus 4f equals 46. Minus 3g minus 4f equals minus 4. That means now I have to go back to the question and try and find out more pieces of information because these are parallel lines. You know, they don't have a point of intersection. You know, it's not going to work out. So I need more information. And if I go back to here, and I've tried, like I have tried all the formulas in my log tables. I have tried the perpendicular distance formula. I can't find the lengths of these two things here to use Pythagoras. So now I'm looking at kind of a tricky enough question where that's my problem solving go-to list. So what do I do next? Well, maybe I just need to start thinking about other things that aren't in the log tables that I know from junior cert. So where a point cuts the x-axis maybe, or a point cuts the y-axis, or a point is on a line. If a point is on a line, you can sub it in. And this point here, minus g minus f, is on this line here, which I worked out at the start. So if a point is on a line, I can just sub it in and know that it'll, you know, the left will equal to the right. So we found out that the equation was x minus 7y plus 33. And if I know minus g is on that line, I can just sub it in, and minus f. And when I clean that up, I'd just end up with minus g plus 7f plus 43 equals 0. And now I have something that I can work with. So I can do simultaneous equations with that and this one, and find g and f. So when you do that with this one here, and this one here, you'd end up with that G is, so I'm not going to do this out, you should be able to do junior cert simultaneous equations. Which means the centre of my circle is 6, 7, and I know the radius from the start is 5. And you just do the same thing with this simultaneous equation and this one, sorry. And when you work that out, you end up with G is 8, F is minus 5, which means the centre of the circle is minus 8, 5, and radius 5. And all you have to do is fill that into the equation of a circle formula, and you have your two answers.